Good morning students. Today we'll do chemical reactions of amine. In last class we have studied about the basicity of amines, why amines are basic in nature. So today we'll do about the reactions. So number one reaction with haloalkane. Haloalkane means alkyl halide. This is one of the amine RNH2. When it reacts with some haloalkane like RX, yeah, as you know, this is primary amine. When it reacts with haloalkane, it will convert it to secondary amine by removing one hydrogen like this. I mean, you will get secondary amine, and the removing hydrogen combined with halogen, it produces side product HX like HCl, HBr. Similarly, when the secondary amine reacts with another haloalkane, then it will convert to tertiary amines. Side product will be H6. Again, when this tertiary amine, already you have got this reaction, nitrogen have one lone pair of electron, na? That's why tertiary again can react with another haloalkane. Then it will form a quaternary sol like this. Due to presence of lone pair, it can combine with another R. So R dash, R double dash, this is R triple dash. This become positively charged and X minus. I mean, it produces sol, and this is called quaternary ammonium halide. X is said to be halide. If X is chlorine, then you can write chloride, bromide like that. So when amines reacts with haloalkane, the amine will, if the amine is primary, it will be converted to secondary, and when secondary reacts with another haloalkane, then it will convert to tertiary amine, and when tertiary amine reacts with another haloalkane, then it will convert to quaternary ammonium halide or quaternary sol. So this is the first reaction of your amines. Now second reaction, this is very important reaction with chloroform. Reaction with chloroform, and this reaction have a specific name, carbolamine reaction. Carbolamine reaction. What is called carbolamine? Actually, carbolamine is a compound and which have very bad smell. And when you carry out this reaction, if carbolamine is produced, then you will get that bad smelling. And like this way, you can confirm that your carbolamine is produced. And this reaction is specially used to identify the organic compound, whether it contains amine functional group or not. So if you want to determine amine functional group, whether one organic compound contain NH2 group or not, to find out that, you can apply this reaction, which is called carbolamine reaction. The reaction is like this. When amine reacts with chloroform and sodium hydroxide, you can take potassium hydroxide also, alcoholic, some amount of heat is required, then the compound is converted to like this, which is called alkyl isocyanate, and this alkyl isocyanate is also called carbolamine. This is also called carbolamine. And side product, you will get potassium chloride water like this, and this carbolamine, it has very bad smell, bad smelling compound, and this reaction is used as a test to perform amine functional group. Number 3 reaction, this reaction is very important. Only amine can show this reaction, not by other compound. For distinguishing purpose also, you can apply this reaction. Number 3 reaction, which is called Hofmann mustard oil reaction. Hofmann mustard oil reaction. This reaction is called mustard oil. I mean, you will get the smell of mustard oil in this reaction. That's why the reaction is called mustard oil reaction. What about this reaction? When amine or NH2 reacts with carbon disulfide is like this, CS2, like carbon dioxide. When amine reacts with carbon disulfide in presence of catalyst mercurous chlorides HgCl2, then it will form a compound Rn double bond C double bond S, which is called alkyl isothiocyanate, and side product will be mercurous sulfide HgS and HCl, and this compound give the smell of mustard oil. That's why the reaction is called mustard oil reaction, and this one carried out by Hofmann. That's why the reaction is called Hofmann mustard oil reaction. This reaction also you can use for the distinguishing purpose for amines. Number 4, reaction with nitrous acid. Reaction with nitrous acid. Amine, when reacts with nitrous acid means HNO2, and you know it is prepared by mixing NaNO2 and HCl. When you mix these two, then you will get nitrous acid, because nitrous acid is not available in lab. Nitric acid is available, but nitrous acid, if it required, then you have to freshly prepare by mixing NaNO2 and HCl. And when they mix, they produce the nitrous acid. So when it will combine with nitrous acid, then it will convert it to directly alcohol. Side product will be nitrogen and water molecule. So if you want to prepare alcohol from amine, then you can prepare like this. Actually the reaction is like this, RNH2 amine, and the nitrous acid you can write HONO. This part will break like this, this part will break like this. This produce ROH alcohol, this will form nitrogen molecule, and this will form water molecule. So this is the reactions of amines. Now I will give you one question. How will you distinguish primary, secondary and tertiary amines? See, suppose someone provide one amine in a test tube, and if it asks you identify whether the amine is primary, secondary or tertiary. So how to find out this? By doing some tests you can find out whether your amine is primary, secondary or tertiary. This for this distinguishing purpose you can apply one test which is called Hingebug test. I mean, you have to use Hingebug reagent, and by applying Hingebug reagent you can find out, you can distinguish whether your amine is primary, secondary or tertiary. The Hingebug reagent is this one. This one is used by Hingebug. And this compound is called benzene thionyl chloride. This compound is called the Hingebug reagent. I mean, Hingebug used this compound. When this compound reacts with amine, this is your primary amine, then it will convert to a compound like this. Ring will remain same. This chlorine combines with hydrogen, it produces HCl, and this NHR will join with it. This compound is soluble, it gives the precipitate, and it is soluble in potassium hydroxide. I mean, when the compound give the precipitate, if the precipitate you dissolve in KOH, potassium hydroxide, then the precipitate become soluble. But the same reaction, benzene sulfonyl chloride, when you react with secondary amine, then also reaction takes place. It will form the compound like this. Here also you will get the precipitate, but the precipitate is insoluble in KOH. The difference is like this. Here the precipitate will be soluble, here the precipitate will be insoluble. Same reaction, if we apply for tertiary, this is your tertiary amine. Here no precipitate, I mean you don't get any reaction here. So by applying this reaction you can find out whether the amine is primary, secondary or tertiary. So when you get the amine, first time you apply benzene sulfonyl chloride. After adding benzene sulfonyl chloride, if you get the precipitate, you see whether it is soluble in KOH or not. If it is soluble, that is primary. If it is insoluble, that will be secondary. And if there is no precipitate, that will be tertiary. So like this you can distinguish primary, secondary and tertiary amines by applying Hingebug test. Thank you.